Hey, welcome. So today we're going to dive into the International Baccalaureate's Middle Years Program, or MYP, and really demystify its unique and I think really powerful approach to assessing mathematics. All right, I want to start with a question for you. When you hear the words math class, what's the first thing that pops into your head? For a lot of us, it might be long equations, those stressful timed tests, and just this laser focus on getting that one single correct answer. But what if there's so much more to it than that? Well, this is where the IBMYP philosophy really flips the script. It argues that math should be way more than just memorizing formulas and hunting for the right answer. It's all about understanding the entire process, the thinking, the exploring, and yeah, even the communicating that goes into solving a problem. So here's our game plan. We're going to walk through the 4 key pillars of MYP math assessment, and then we'll tie it all together to see the bigger picture of what this all means for you as a learner. Okay, let's jump right in with our first pillar, Criterion A. This is all about knowing and understanding your tools. You can think of this as the foundation of your entire mathematical toolkit. Basically, it's about knowing your stuff. Can you look at a problem, maybe one you've seen before, or maybe something totally new, and know which tool from your mathematical toolbox is the right one for the job? And just as important, can you actually use that tool correctly? And you'll notice, this is about so much more than just getting the right answer at the end. The MYP approach actually looks at the whole thought process. First, can you select the right method? Then, can you apply it correctly? And finally, does that process lead you to a correct solution? Each step is its own crucial skill. All right, next up is Criterion B, and this is where things get really fun. This is where you get to be a bit of a mathematical detective, investigating patterns. I love this one because it's all about the thrill of discovery. This isn't about just following a recipe somebody gave you. No way. It's about asking questions, taking some smart risks, and using your brain to find structure and relationships that aren't obvious at first glance. This process is basically what real mathematicians do every day. It starts with just spotting a pattern. From there, you try to describe it, maybe turn it into a general rule. But here's the kicker. The final, most important step is to justify that rule, to actually prove that it works. That's how an observation becomes a mathematical fact. Okay, so building on that, we have Criterion C, which is based on a really cool idea that math is a universal language. And just like any other language, being fluent is key. Think about it. It's not enough to just have a brilliant idea in your head, right? You've got to be able to explain it clearly to someone else. This criterion looks at how well you can use the right symbols and terminology and present your work so that it's logical and easy for anyone to follow. So what does this mean in practice? Well, it means a messy, disorganized solution is actually an incomplete one. Using the correct symbols, picking the best way to show your data, like a graph instead of a table, and organizing your work into a clear argument, those are all essential math skills. And now for our final pillar, Criterion D. This one answers that age-old question that every single math student has asked at some point. When am I ever going to use this? Well, this is where the rubber meets the road. It's about taking all those abstract ideas from the classroom and using them to solve genuine, real-life problems. It's about seeing math for what it is, not just a school subject, but a super practical tool for making sense of the world. And the process here is actually pretty deep. You don't just spit out an answer. You have to justify how accurate it is, and this is my favorite part, you have to justify whether it even makes sense in the real world. I mean, come on, if your calculation says you need 3.7 buses for a field trip, you have to have the common sense to say, okay, we're ordering 4. And we're not talking about those weird, abstract word problems about 2 trains leaving a station. These are real, tangible challenges. You could be using stats to analyze an athlete's performance, applying geometry to a design project, or even building a model to figure out the best cell phone plan. Okay, so we've looked at all 4 criteria. Let's zoom out for a second. What's the bigger picture here? Why does all of this actually matter? Really, what it all boils down to is this. While traditional math often just cares about the final answer, the MYP framework values the entire journey. It recognizes that the real learning, the deep learning, happens in the process, in the thinking, the investigating, the communicating, and the applying, not just in getting to the destination. So what's the end game here? It's about building the skills and qualities of the IB learner profile. By working with these criteria, you're not just getting better at math, you're becoming a better inquirer, a clearer communicator, a more thoughtful thinker, and a more confident risk taker. These are truly skills for life. And this isn't some brand new idea. The philosopher Roger Bacon figured this out way back in the 13th century. He basically said that if you don't get math, you can't really get anything else, not science, not the world. It's the key that unlocks a deeper understanding of everything else. And that really brings us to a final thought to leave you with. The whole point of the MYP framework is to get you to see math differently, not as just some subject you have to pass, but as what it really is, a powerful, universal language that you can use to explore, to question, and to understand the entire world around you.